Hi guys, hope you're all having a good holiday season so far. I got a quick tutorial for you today. This one's inspired by this Blender node. I've been learning Blender for the past two and a half weeks, and I'm really digging it. I'll be making some tutorials for Blender after the new year. But they have this node called Accumulate Field, and it allows you to do stuff like stacking random stuff up on top of one another. Um, And I wanted to replicate this effect in Lightwave. And you can do it. The way that we do it is with using Lightwave's built-in dynamic system. And so basically we have these points that we're deforming somewhat randomly, not fully randomly, and then we're accumulating those values with these particles. And that's basically replicating, and you could do way more than this. I just did this for this scene, just for this particular setup. Now, just to show you how this works, if I go into, I have this thing called Stacks Master. If I go into Setup, and if I add a bone, call it Stack, you can see it'll create an instance. There's actually 20 there. So if we go into the instances for our cube, well, there's only one because you'll see the way I have it set up here is, if I go into the bones here, I want to put this rest length on 20, and I want to put it on joint, and I'll put the scale pretty high. We'll do 10,000. Now we'll do 5,000. 2,000. Okay. So that gives us this. Now if you'll see, if we go into the instances, you'll see we have 20 instances. So if I go into the bone, and I can also scale these up like this. If I turn on Studio Live, you can see. And if I clone that, I can Control C. See? And that one's giving me these random values plus these accumulated values. I'm just placing them where you're getting. If I Control C again, it's giving me these values. Now, the way I also have this set up, I did a bunch of different controls on this. Now you'll see these other ones down here are different. What that does, if I go into the scale, if I scale these on the Z, you can see that's going to fade between this value here and this value here. So I have it set up like that. And I also have it set up so that you can uniformly scale it. And you can also, so we can do this. And we can rotate and move it individually per bone. And then for the servicing, I didn't set up too much. I just did a quick little setup. So that's basically all we're going to do. Let's just get started. So all we really need for this are the data points. So I'm just going to load this object called data points. It's just 200 points on the x-axis. I'm going to change them to vertices and put them on red so we can see them. And so all we're going to do is we're going to use these points as our data points. So I'm going to go into the deformations, go into the nodal. Just going to get a true art split vector, and we're going to split out the X channel. We're going to get a mod, and we're going to mod X by, I'm going to get a global variables here because there's a few values I want to use through all these node networks. So I'm going to use the max stack height, which is going to be 20, and 200, which is the max points. So we're going to mod that by 20. So that's just going to count the 0 to 19 over and over again. So if we get a remap here, I want to remap that amount. And we're going to tools make vector. And we want to displace these on the Z axis. So you can see it's displacing them all right now. But we need to remap that value. So we're going to we want to remap it from, we need to go from 0 to 19 basically. So if I go to add, and if we subtract 1 from our stack count, that'll give us 19. And if we go into the in-max, now you can see from 0 to 19 it goes from 0 to 1. And the only reason I'm doing this is because I didn't want completely random stacks. I wanted a way to control this data. And this gives you a ton of options for ways to control this data. And so I'm getting a waveform here. I'm getting a bias. And being able to use these waveforms with that remap is really, really powerful. I didn't do it a lot until recently, but there's really a ton of power there, a ton of ways to remap this data. So I'm just using the bias on that remap data there, and you can see it's going to make the boxes bigger at the bottom and then get smaller as they get toward the top. Just adjusting the settings in the bias. So now the way we're going to randomize this is we can use that shift in the bias. So I'm just going to get a random scalar, and what I want to do is I want to get the same random number for the first 100 as I do for the second 100. So I'm going to divide the max by 2. That's going to give me 100. And then I'm going to mod the x by 100. So that's going to just cause that for the first 100 points, it's going to give me one set of random numbers, and then it's going to replay again for the second set of points. And you don't have to do it that way. But I'm just doing it that way because I just wanted to go that way with it. So I'm just going to affect that shift from 0.75 to 1.1. And if I go into the shift, you'll see that it'll randomize those curves slightly. But what I want to do is that for the second half, I don't want them to have any of that bias. I just want them to be fully random. But so what I'm going to do is, for the second half of points, we're going to, so we're going to get a divide here, and we're going to floor that. So if we divide the x by 20, it's going to give us groups of 20 basically. So first group will be 1, second group will be 2, or 0 and then 1. So what we can do is this, we can get a logic, and we can say if this floored amount here is greater than 4, so that'll be the second group of 100, then we can have, we'll make the phase, if it's true, we'll have the phase equal 1. If it's not, we'll have it equal 0.5. So if we go into the phase with that, you'll see that the second group are at the highest point of that curve there. Basically, I just shifted the phase over so that they're all at the top end. So we're getting the same shift offset, but just without the bias. And like I said, there's 1,000 ways to go about setting this up. This was just a way that I could get a lot of data with some sort of organization to it. So that's pretty much it for this part. So for the next part of this, what we're going to want to do here is we want to create a particle. So I'm going to clone this. I'm going to clone this object. Then I'm going to turn the deformations off for it. And then what we're going to do is we're going to add an emitter to it. Add emitter, 200. We want to have the same number of points by the frame on the vertices. Size no change. Particle limit 200. Fix that. The negative stack count basically, so negative 20. That'll cause all the calculations to be done before frame 0. So we want to turn the weight to 0, turn the position blur apparent motion to 0, and that's pretty much it. So the next thing we got to do here is add the force that we're going to use to push these particles to accumulate this data. So I'm just going to call it data accumulate wind. So we're going to turn the radius to 1, power 100, fall off to off. Heavy wind, that's important. Make sure everything's zeroed out. So what we're going to do is we're just going to use this wind to push these points so that it accumulates the data for that point and all the points previous to it. And so I'm just changing the color for the points. So the way we're going to do that is we're going to go into the direction for the wind, and we're going to add node texture to it. So we're going to go into the node editor. So the first thing we're going to need here is we're going to need to get these points in here. So I'm going to get a dpkit item info point info and a dpkit item info nearest point, and we're going to get a AS tools time, and we're going to get our constant variables, and we're going to get an add, a mass scalar add, because we got to add one or subtract 1 from the point index because we want to start our calculations at 0. And I'm selecting the second layer for our nearest point, subtracting 1 from the index. Then we're going to mod that by 20. And what we're going to do is we're going to get a logic. And what we're going to do is because basically what we want to do here is that we want to turn the wind off for each previous frame. So we're going to get the frame number. We're going to add 20 to it because remember we're starting at -19 and we need to match up with these points. So we got to add 20. And we're going to say if that frame number is less than or equal to B, then we're going to feed in one value, and if it's not, then we're going to have it be 0. So now we're going to divide by 20, and we're going to mod floor that, and then we're going to multiply that. We're going to multiply that by 20. Now if we add that to that frame index there, that will give us the correct point that we need to be getting the value from here. So I'm going to add 1 because the point index starts at 1. So now that's giving us the correct point that we need to be getting the velocity from. So we're going to get a split vector and a make vector. And we're going to get a multiply because we got to multiply by the frame rate. So we're going to get the z coordinate of our deformed points. We're going to multiply it by 30, which is the frame rate. And we're going to use that as our true, and the false is going to be 0. We'll go into the z. So now if I was to scrub the timeline, you'll see that all the particles will jump to where they're supposed to be. I could also just turn the wind on and off. I'm turning the frame to 30 because it'll calculate quicker. So now you can see once I drag the timeline, it accumulated, each particle accumulated that there's displaced points data for each previous point basically. So all I did was I turned the wind off for the first point on the first frame and the second point for the second frame, and then accumulated all the data. That's what that node network right there is doing. It's not really that complex. If you're having trouble figuring it out, just go along with it and you'll be able to tell what it's doing exactly. But that sets up the accumulate data. So that's it for that part. So the next part of this, we got to deal with creating these stacks of instances. So I'm just going to make a cube here. I'm going to use the default settings because it's actually set up the way it needs to be. And I'm just going to go in. I'm going to make sure that don't render. I'm going to put it on wireframe because I'm going to put the instances on this, and I don't want that base one rendering. So I just added DP instance to the cube. I'm going to add the cube, put it on grouped, pivot, Max instances 500. So there's 500 instances all stacked on top of one another. So we'll go into the nodes for that. So basically what we're going to do is we're just going to split these out and use these points to split these out into stacks and then control the stacks with it. So I'm creating a node called stack master, and I'm going to add a bone to that. And I think using bones is a nice way to do this. I just called the bone stack. I'm going to go into the properties for that. I'm going to turn the rest length on 20. That'll become important later. And I'm going to put it on joint. And I'm going to turn the icon size to 400. So that'll just give us a little representation there of our bone. And I cloned it just because I want to have a couple of these to work with just to make sure our setup's working right. So we got these 3 bones. And what we want to do is we want to use these bones to manipulate our stacks of 20 or whatever we want them to be. So I'm going to get a instance info, and I'm going to add 1 or subtract 1 because that starts at 1. We want to start at 0. And we're going to get a divide and a mod, or a divide and a floor. And we're going to get our global variables. So we're going to divide the index by 20 and floor that. And that'll give us groups of 20. And what we're going to do is we're going to get an item info, bone info. I'm going to select our stacks master as the object. And for the bone index, what we're going to do is I'm going to add 1 to our floor to mount there. And what that'll do is that'll put each group on a bone. So groups of 20 will go on the bone. So if I go from the position into the position, you'll see now there's 20 stacked on top of one another right there, but you'll see that it puts them on the bone. So I'm going to put an add because we're going to have to add to that position. So the first thing I'm going to do here is make it so we can clip these so that we're not drawing all 500. So if I get a mod, we just mod that by 20. So we can get a logic here and use that rest length that we have to clip our stacks all at 20. So if we say if that modded amount is less than the rest length, then we'll just have it equal 1 if not. I forget if it's greater than or less than. I'm going to have to look at it. So it's A greater than B. So now you can see there's only 60, but there's 20 stacked up on. So you can look at there's only 60 instances, but they're all stacked on top of one another. So it's A greater than B. So that makes it so that when we clone these bones, it'll keep the instances at the proper amount. So now what I'm doing is I'm getting a point info and a particle info, because we need to get the info from the points and the particles. And we're going to get a split vector. We're going to need 2 of them. So what we're going to do, we're going to select, for the first one, we're going to select the points layer. And for the second one, we're going to select the particles one, which was the second clone we made. So now we're going to get a math scalar divide. We're going to divide that by 2 because, like I said, remember we're repeating here. So I only want to we got a mod by 100, even though we have 200 points, because we're repeating this pattern over again. So I'm going to add mod by 100. I'm going to mod this index by 100. And I'm going to add 1 because the point index starts at 1. particle index starts at 0. So now what we can do here is we can use those amounts to transform our instances how we need them. So if we take the z from the points and go into the scale, you'll see that it'll scale our particles based on those random points. Well, with the bias, the random with the bias. And then what we can do is we can use the position, the z position, to stack them up. Now you'll notice they're a little messed up because what ends up happening is that first box in each row only needs to be scaled. It doesn't have to be moved. So what we can do is we can get a logic, and we can say if that mod is greater than 0, do one thing. Or if it's equal to 0, do one thing, and if it's not, do something else. So if it is equal to 0, so now you can see the first one, it doesn't move it at all. We're just scaling it. You can see we can move them around, up and down. Clone it, and it all still works. You can see we should have 80 instances now. So what we want to set up now is we want to be able to cycle through these. We want to be able to fade to that second section. So we're going to need a second set of these points. So I'm going to grab 2 more point info and particle info. And what we need to do is we just need to add 100 to this modded amount. So I'm just going to take that modded amount and add 100. And then we can go into the points and the particles. So now all we need to do here is get 2 remaps with clamped values. And all we're going to do is we're going to use the z scale of our bone. So I'm just going to get a split vector. I'm going to get the z scale of the bone here. And all I'm going to do is I'm going to put that into the input for our remap. And then what I'm going to do is I'm just going to use that scale to fade between these 2 values. So the 2 points will fade between point info 1 and point info 2, and fade between particle info 1 and particle info 2. So now you'll see if I hook these up, if I take the scale into the scale, that's the point info, you won't see anything happen for either one of these. And if I take the position into the position, but what you'll notice is now if I take these bones and if I scale them on the Z, I'll be fading between those 2, basically, those 2 versions, the version on the bone and then the version plus 100. So that's pretty much all there is to that. So for the next part of this, what we're going to do here is we want to we want to be able to rotate and scale these. I want to be able to scale these as one unit. And the way we can do that is, so I'm just going to take the position into this delta for this scale node. And I'm going to take the delta into the position on the outside. And for the scale, I'm going to use the X scale of our bone. And for the center, I'm going to use the position of the bone. So now you can see I use the rotation box and I use the position for the center. So now you can see if we scale it on the X, it'll scale the positions. But what we need to also account for that in the scale of the instances. So the way we do that is we could just multiply the scale we have now times the scale of the X of our bone. And we'll go into the scale. Now you'll see we'll also be able to scale these uniformly too, which I thought was pretty cool. I'm just trying to show you different things that you could do with this to make it more elaborate. Now what we're going to do is we're going to get the rotate, and we're going to give us the ability to, so that when we rotate the bones, so we just took the delta and then the delta and back into the position, use the position as the center, and for the rotate, we'll just use the rotate. So we got to go in for the rotate for the instances, and then the rotate for the transform on the position. And now you'll see when we rotate, we could still, each one of these are relative to that bone. So we can move, scale, and rotate the bone, and it'll all be relative to the bone. So now for the next part of this, I thought this was a cool addition. What we're going to do is we're going to get a remap, and we're going to go in with this mod. So that's the modding the index by 20. And what we're going to do is I'm going to take the Y into the input for the in min, and we're going to do the Y scale +1 for the in max. So we're cycling through these indexes, and we're going to scale them from 0 to 1. Or 0 to the scale that they already are, which is that multiplied amount there. So you'll see it gives a I thought this was a pretty cool effect. And then we'll go into the scale with that, and you'll see what that does. So now if we go into the scale for these bones on the Y, so now the X, Y, and Z scale are all controlling different aspects of this. You can see what it does. It grows each one out, and then it grows the next one. See how it's scaling it out? I thought that was a pretty cool effect. So that's pretty much all there is to. That's all I'm going to do. I mean, there's so many other things you could do with this, but I feel like that gives you a good idea of what's possible. So what I'm doing here is I'm just getting the waveform just to show you how you can use these waveforms. I really like being able to use these in the remap node. So now you'll see when I scale these, the bias for you can really get a lot of cool effects by using these waveforms into this remap. And I'm just going to use it for the fade in between as well. I just like it so that I don't have to worry about doing it in the animation. It just does it automatically. So that's the fade between each one. That's actually the scale. It's this one that I just set up. So you can see it starts out fast and then fades quicker to the other one. I was just showing you how you can use them waveforms to affect those remaps. So I'm just deleting all of them. I'm just setting this up so we can get some surfacing on it. I'm not going to do too much with the surfacing, so I clone that bone 20 times. And now all I'm doing is I'm going to move the last one pretty far down on the X. And then I'm just going to select them all and distribute them along between those two. So you can see all it's doing is it's repeating the same 5 random ones over and over and over again. Now, if you wanted more, you could add more points, but to demonstrate this was fine. So I'm just making sure everything's working as I expected. There's the fade from the one to the other. I believe I also show you how you can adjust, like what I do. I think I go into the deformations for our original points, and I think I change them just so you can see that this is all live. So if I change that random value to something much more, I'll go from 0.5 to 1.5. So now that shift is going to be much more random. And you can see it already affected the scale. But in order to get we got to go to the wind and just turn it on and off, and that'll update it. So now you can see, you can very easily, it's all live pretty much. So everything still works. So you're able to just, even if I scrub the timeline, that wind would have also have updated, but it just needed a refresh. That's why I had to turn it on and off. So I mean, it's pretty much live. Just making sure these are all working. So that's pretty much it for that. Let's do the servicing. So the first thing we want to do is we want to save out this cube because that wasn't saved. So I'm just going to save that cube, call it cube, save it out. Now we want to create a ground plane for this. I'm trying to set up a little bit of an environment for lighting. Like I said, I'm not going to go too crazy with this, but I just wanted to show you some stuff you could do with the servicing. Turn off our light because I'm going to use GI for this. Set the camera up. I think I go into the camera settings here. I'm just turning the backdrop up a little bit just so it's not completely black because I want to have a little bit of global illumination from the backdrop. Turn off ambient. Turn on global illumination. 4 bounces because I'm going to use emissive geometry here, so I want it to have enough bounces. Turn off the settings we don't need. So you can see we're getting some global illumination from the backdrop here. Okay, so let's deal with the servicing on these on the boxes. So what we're going to do is we're going to get a DP kit, item info, instance info. We're going to get a mass scalar mod, mass scalar divide, and a floor. And we're going to floor and mod that instance index. You got to keep in mind the index in the service editor starts at 0, but in the instance node editor it starts at 1. That's one thing to keep in mind. So I'm just going to mod by our global variable, divide by our global variable. Going to the floor. Going to get a color tool. Just going to pick any color. It really doesn't matter. Go into the color. Now what we want to do is we just want to affect some of these parameters of this color tool. So I'm going to get a remap. And I think I'm going to get a multiply. Because what we want to do is we want to multiply by that floored amount there. Multiply by 0.3 by the floored amount. And we'll go into the hue with that. And you'll see that'll just shift the hue per that index from one side to the other. So that's just giving you per bone, basically, per bone shift on the hue. Now what I'm doing here is I'm going to get a split vector, and I'm going to get the scaling of the instance just on the Y. Doesn't really matter because we're scaling them uniformly here. And I'm going to remap that from 0 to 5. I'm going to the saturation. You can see now it'll saturate and desaturate those based on the scale of the instances. Now, one other thing I want to do is I want to make one in each stack luminous. And the way we can do this is I'm going to get a random number based on that floored index there. I'm going to get a multiply. I'm going to get an add too, I think. I'm going to multiply by just any number just so we can get a random seed. I want to make sure it's a good seed, so I'm going to add so it's not at 0 at all. So we're going to add some and then multiply and then go into the seed. So that's going to give us a random number per bone, basically. And I'm going to get it between 0 and 19. A random number between 0 and 19. And I'm going to round that. So I get a round. So I round that number. Go into that. If I could say if the index, if that modded index there is equal to this random value, then we'll make the luminosity 100%. And you can see that's what it's giving us now. So there's one in each bone basically is being randomly lit. Now what else I want to do is I want to add a little more saturation to them. So one thing we can do here is I'm just going to take that same amount that we have there and I'm just going to add it into the saturation. So now it'll just oversaturate those luminous ones. It'll give us a little bit more dynamic lighting. So that's pretty much it. I'm not going to go too much crazier with it. There's so much more you could do with this, but I hope this gives you a good idea of different things you can do. So that's all there is to it, guys. Take care and have a good holiday. I'll see you after the new year.